Okay, so here's the graphing practice we did in class today with the half-life. We did a lot of this on the board, but I just wanted to show you from start to finish. So it says the half-life of a radioactive substance is 6 hours. It's currently 600 grams of the substance. So let's go ahead and underline some stuff. Half-life, 6 hours, currently 600 grams. So the missing information, number of time periods. And I know the time periods each are 6 hours. So let's say the number of 6-hour time periods or periods of time, or we said chunks of time, however you want to say it. And then Y would be, after so much time passes, it'd be the final amount of the substance in grams. Okay, so we know that this will be, since it's half-life, it's going to be exponential. So A times B to the X equal to Y. Starting value of 600. B, since it's half-life, my B value will be 1/2. That'll never change on a half-life problem, just by definition. So 600 times 1/2 to the X is equal to Y. And I'm going to go ahead and enter this in. So if you click on Y equals, that'll allow you to enter your equations in. I already have one in here, so let's just clear it. Also, sometimes, for whatever reason, if you aren't able to look at a table, this plot up here may be on. So if you just come up here, click enter, and then arrow back down, that takes care of that. So let's type in 600 times 1/2 to the X power. And let's go look at a table here. Okay, so this looks really strange. It says my first X value is 17. The amount in grams is already really small. It's 0.004. So I know I should start with 600. So I want to see at least that starting value. So when no time has passed, I'm at 600, meaning X is 0. So we did this a few times, but if you want to adjust what's shown in here, hit second window. That'll get you table set options. Table start, I actually want to start at 0. And since this is getting cut in half, I think it's going to decrease pretty quickly. Just after one round, it's going to go from 600 down to 300, then half of that down to 150. I think it's pretty rapidly going to decrease. So let's just keep it at 1. Okay, so we said we would keep this at 1. If I go back and look at my table now, this looks a little more like what we were expecting. So after 0 time periods, 600 grams. After 1 time period, it's been cut in half down to 300. 2 time periods means we're at 150, so on and so forth. Now keep in mind, this 1 does not mean 1 hour. This 1 actually means 1 6-hour time chunk. So that's really 6 hours, it's down to 300. This 2 would mean 12 hours, it's down to 150. 3 would mean, let's see, 6 times 3 is 18. So 18 hours, it's down to 75. So we'll get into that a little bit later down on the bottom question at number 6. But for right now, we have the graph. I'm sorry, we have the equation here. Let's go ahead and graph that. So again, scaling is one of the most difficult things to do. If I'm going to look, let's see, we have 22 boxes here. Since I'm counting by ones on the x's, that means I would get to 22. Let's go look at 22 as an x value. See, already it's like at 0.1, less than 0.1. Like this is really small. I'm hardly even going to be able to graph that. So you know what? I might skip a box and just say, for example, this is 0, let's skip this first one, and the second one is going to be 1, skip 1, 2, skip 1, 3. So really every box would be a half of a time period. So let's try that. And this is why I think that'll be okay. That's going to allow me to get out to 11 time periods. And look at this value. At 11 time periods, I'm already at 0.29. That's like such a small number. It's way smaller than 1. So let's do that, and I'll show you what it looks like at the end. So 6, 7, 8, 9, 10. Okay. So my lowest value is almost at 0. My highest one was 600. So right here, my point's going to be up at the top, right? That's the highest it ever goes. So if that's 600, and I have 22 boxes, let's do 600 divided by 22. Gives me 27. Let's count by 30. So get this number. 30, 60, 90. I'll skip writing 270. Even though I'm skipping a box, you can still notice I am counting for 30 every time. It's just like I'm writing it and erasing it to save some space. 480, 510, 540, 570, 600, and I can stop there. Okay, so let's label. This would be amount of radioactive substance in grams. I guess you could write grams of radioactive substance. This down here would be number of 6-hour time periods. And we'll call this half-life of a radioactive substance. I'll abbreviate for space. Okay, so that's really the hardest part. Now you come back to your table and let's start plotting some of these points. So I have 0, 600, 1, 300, 'So you can notice how quickly it's declining, especially once you get your graph scaled like this. After that second point, it's already on the lower half of the graph. And really quickly here, I'm going to be so small that I'm just going to have to kind of approximate. So okay, so let's see, 10, 11 are pretty much on really close to the x-axis. Okay, so we got a nice smooth curve. Let's answer a few questions here. Actually, I'll keep that screen on here for a second so you can look at it. You can pause it if need be. Explain the significance of the y-intercept in the context of the problem. So I would say we started off with 600 grams. Of the substance. How much of the radioactive substance will remain after 2 days? Okay, so don't get tricked here. We're talking 2 days. Well, every x that we increase by is actually 6 hours. So instead of asking about 2 days, why don't I ask about after so many hours? How many hours is 2 days? Well, each day is 24 hours. So 2 days, it's really 2 times 24 is 48 hours. Okay, we're actually going to have to do a second calculation because my x value is not number of hours, so I can't just scroll down to 48, right? So if x is number of 6-hour time periods, how many 6-hour time periods do I get in a 48-hour window? 48 divided by 6 is 8. So there's 8 6-hour time periods. That's a fancy way of just saying that x is going to equal 8. So what's your y value? What's the amount of substance when x equals 8? So let's look at our table. It's pretty easy just to read it. 2.3438. Let's round to 3 spots after the decimal. So after 2 days, I'm going to have 2.344 grams. Okay, this one's a little tricky as well. 3.75. Explain what that means in the context of the problem. So 3.75. Let's verify that is a point that's going to be on our curve. This means after 3 time periods, I will have 75 grams. But we can be a little more specific than that because after 3 time periods, each one is 6 hours. That's really going to be 18 hours. So we can say after 18 hours. And I'd like you guys to write a complete sentence. I'll just abbreviate for time's sake. I will have 75 grams of my radioactive substance. Okay, so there we go.